Hello students, today we are going to discuss physics from that units and measurements is the topic we are going to cover today for foundation. Okay, foundation. This course is very important. So we are going to strengthen your basics of every concept. Okay, so let us start our topic. So physics. See, what is meant by physics? Physics is all about Physics is all about the study of matter. So whenever you are studying physics, you majorly focus on what is the matter around us, how the matter, physical properties of the matter, such as density, like or else weight. Okay, so if you take motion, what is the velocity, acceleration, all these things we are going to discuss in space, distance, displacement, or where the object is locating. Okay, so all those things we will discuss about space and time and how much time it is taking to move from one place to another place. So like that, in physics we study about the matter, motion, space and time. So here majorly we focus more on energy, different forms of energy we have. Okay, so like electrical energy, magnetic energy, or potential energy, kinetic energy, nuclear energy, gravitational energy. So there are many five types of energies that are present in our nature, so which are interchangeable. Heat energy, so one energy form will convert into another energy form. So we are no we have to find how to measure the energy that is present in any object, so how the energy is changing. So all these things we are going to learn in the physics. Okay, force, say for any body, for creating any sort of motion, for creating any kind of change in its direction or disturbing the inertia of the object, we need force. Okay, so we are going to discuss about energy, force, mass and charge for minute particles. For very small particles, so the charges will be present, such as electron, proton. So there will be charge. So the electron will change everything in physics. So electron is a very important element, which is the smallest element, but it is very important element because of its charge. So all these things we are going to learn in the total concept of physics. Okay, so nature and experimental science that develops theory tested through observation. So here, so physics generally we decode the natural phenomena. So how they are happening like that, and why it is happening like that, what is the logic, so what is the theory behind it. So when you start from Newton, he has decoded the gravitational energy, gravitational acceleration. So why when he saw an apple falling from a tree, he understood that there is some sort of energy or some sort of force that is pulling every object down, that is gravitational force. So likewise, every natural phenomena is linked with some logical thing in physics, so which we are going to derive the observations which we understand, that will be converted into a logical explanation through experiments. Okay, so here in physics we are going to go into different genres, or you can say different branches of physics, such as mechanics. So this is one branch in which we deal with the moving objects. Heat, where we deal with the movement of the heat energy from one place to another place. So we totally discuss about the heat, how heat is traveling, how heat is getting converted into other forms of energy, or light is another form of energy. Okay, astronomy, so how the planets are existing, or how the solar system is this much stable. Okay, so what is the principles behind it, and the trending topic nowadays, that is quantum. So quantum means, as I told, it's a minute particle called quanta. So the discovery of quanta has laid a new uh, path in the physics. See, quanta, once the Max Planck discovered this concept called quanta. So then the complete how we see the physics. That means before discovery of this quanta, so the physics was seen in the form of classical notation. So after the discovery of the quanta, the completely the way how we look the physics has changed, and new branch of physics emerged, that is quantum physics. Okay, that we are going to discuss. So now how heat engines work. So that will be understood in the topic called thermodynamics. So wireless communication, how a wireless communication works, that you will understand from electricity and magnetism concepts. So computer revolution, the chips, so semiconductors. So all these things we will discuss in the semiconductors topic. So physical laws. So whatever the observations we make, and then we will do some sort of experiments to understand those observations. So from those experiments, some important laws like Newton's laws of motion, the law of conservation of energy, okay, all these things came out of some experiments we make to prove the natural phenomena. Okay, so now we are starting with our first topic, that is units and measurement. So measurement, see, any physical any physical matter needs a measurement and a unit. So that means whenever you are doing any sort of work or any kind of experiment, we come across many values, such as, for example, you are doing an experiment, how much HCl is reacting with sodium hydroxide, for example. So now how much means what, how many grams or how many liters. So now when you are conducting an experiment between an acid and base, you are conducting an experiment between acid and base. Now you want to know how much acid is utilized, how much base is utilized, how much means what, such sort of measurement is necessary. So likewise, so when you are riding a bike, so you might to know how much distance you have covered, what is the velocity with which you have traveled, and what is the acceleration of your motion. So all these things are the physical quantities which we need to measure when we are doing any kind of work. So now that is the reason why, so everywhere, it may be physics or chemistry or any other subjects also, measurement and unit are very much necessary for studying any subject. What is a measurement? It is a magnitude. So see, when I ask you your height, you will tell that my height is 45 centimeter or 100 centimeter or 150 centimeter, like that. Means what? 150. Here you are telling your height as 150 centimeter. Means what? So here you are seeing two things, 150 and another one is a centimeter. So this 150 is the measurement. So this is the measurement, and centimeter is the unit. This is unit and this is the measurement. Likewise, so whenever we are doing any sort of experiment, you come across two things, one is measurement and another one is unit. Okay, so measurement defines the quantity, and unit will tell you in what form you are measuring that quantity. The same thing can also be written like this, 1.5 meter also. So 1.5 meters. See here, this is another unit, this is another unit, which is a bigger unit. This is a bigger unit. When unit is becoming bigger, the magnitude will becoming smaller. See, when unit is bigger, see, meter is bigger unit than centimeter, because meter is this much, centimeter is this much only. So centimeter is a smaller unit, meter is a bigger unit. So now when the unit is becoming bigger, the magnitude value will become smaller. Here the magnitude is 150, here the magnitude is just 1.5. So likewise, when the unit increases, magnitude of the measurement decreases. So fundamental units, see, whenever while deriving the physics or any other subject, while for doing any sort of measurement, basic fundamental units are the building blocks. Means when you construct any blocks, you might play a blocks game in your childhood. So the basic blocks you arrange, and then on the top you arrange n number of blocks. So any number of blocks you can arrange, but what are the basic blocks are called fundamental. These are the basics. So without these fundamental units, you cannot derive any other unit. So the fundamental basic are majorly three. Actually there are many more than these three, but majorly we see the three units: meter for length, so meter for length, kilogram for mass, and second for time. So likewise, so we majorly take only three fundamental units which are important. There are other fundamental units are also there. I am not saying only three are there. Other fundamental units are also there, but majorly in dimensional analysis, whenever we study, we majorly focus on three fundamental units only. Those are mass, length and time. Mass, M for mass, L for length and T for time. Okay, these are the three basic fundamental units we majorly use. Any other unit you are creating using these three units. So using these three units you are creating new units like Newton. So how you can create a Newton? How you can create Newton? So Newton means what? Force. Force is mass into acceleration. Here mass is, it can be written like m into acceleration is distance, velocity by time. Acceleration is what? Velocity by time. What is velocity? Displacement by time. Displacement by time. So displacement by time by time. So now when you simplify the any formula, you will come to the fundamental units. Any formula you see, finally you will come to fundamental units. See here, mass is a fundamental unit, m for mass, s for displacement, which is the length again, t is a time, a fundamental unit, again t is time, that is fundamental unit. Now rewriting this equation, so force can be written like this, m into s by t square. Okay, this t will come down, this t will come down, t square. So now what is the fundamental unit representation for mass is m, time because this is length, for length L, for time t square, but it is denominator side, so when I take it to the numerator it will become t to the power minus 2. ml t power minus 2 is the dimensional formula of Newton, whereas this is a derived one. From where I have derived, I have used the three basic fundamental units. So MLT, I have used MLT to derive this Newton's dimensional formula. Okay, so likewise, so we are going to learn all these things in the coming slides, don't worry. Okay, now likewise, using the fundamental unit, we will derive all other type of units. So fundamental units are the basic units. We use these fundamental units to derive different types of units such as Newton, joule for energy, like that. System of units, as I told you here, so sometimes you might measure smaller quantities like weight of gold. So you will not measure the weight of gold in kilograms, or bigger units are not necessary, because in your life you have to sometimes need to measure smaller quantities. When you are taking an infant baby to any clinic, first they will measure the weight of that baby. So generally whenever we measure our weight, we will stand on a weighing balance and we will look for our weight, whereas for small babies they cannot stand. What they will do, they will keep another type of weighing balance on which we can make them to sleep and measure. See, measuring a baby needs a smaller weighing scale or different measurements. When we are measuring the weight of a moon, which is very bigger than a human being, there we cannot go with the same weighing balance on which you are measuring a baby, and the same unit may not be fit for measuring that much bigger moon. In the same manner, when you are measuring a distance between your school and your home, which may be 1 kilometer, 2 kilometer, like that, but the same thing, the kilometer is the unit which I am using here to measure the distance between school and your home, but the same unit may not be fit for measuring the distance between moon and sun, or earth and sun. So because if you measure with kilometer, many lakh kilometers are necessary to measure that unit. In that way, so we take different system of units for our convenience. Sometimes we measure smaller values, we can go with a smaller unit system. When you are measuring a bigger values, we go with the bigger unit system. This is one concept. Another one is, before emerging of uniform systems, international systems, of unit. Every country have their own type of system of units. See, for example, in USA, till date, till today also, they measure the weight in pounds. Till today, USA, they don't measure. If you look at any textbook printed in USA, so in those, the questions, in all the questions, they will represent the unit of mass as pound only, or lobes. Okay, so like that they use foot for measuring the distance and second for time. Similarly, another system of unit which is a smaller system of unit, that is centimeter, which is a smaller measurement than foot or than meter. So likewise, gram is also when you measure gold, when you purchase gold, so you purchase in grams only. There you don't need to go with the FPS system or MK system. We don't purchase pounds of gold or kilograms of gold, we cannot purchase there. It is better to use with CGS system. Okay, because we hardly purchase gold in 22 grams or 2 tulas means 48 11 grams, 22 grams, like that. Okay, so for that measuring, whenever we are measuring smaller values, we will go with the smaller units of system. Bigger values, bigger units of system. And sometimes regionally some unit system may be popular there. Likewise, FPS in USA, MKS in UK, like that. So these systems were there. Now later on, to reduce the difference in the system of units, internationally we bring a uniform system. Over throughout the world, we use only one system, that is SI system. So international system of units, international system of units, this is a MKS version only. Okay, so it is MKS system, but we have increased the base units, fundamental units, to 7, okay, than 3. Earlier it were only 3 fundamental units are there, mass, length, time, but we have increased it to 7 basic units, means 7 fundamental quantities or fundamental units, and 2 supplementary, these are in extra, afterwards it came. So 7 were the basic and 2 supplementary units are there. Let us see what are they. First one is length, is the first fundamental unit. Length is the first fundamental unit. Here, how we define length? See, when you are measuring length, we measure it in centimeters, meters or kilometers, but there should be a derivation. Everywhere the meter should be same. In India, the meter is this much, and in Europe, the meter cannot be different. In Europe or India or anywhere, in Russia, in China, anywhere, the meter means the measurement should be same only. Meter means the measurement should be same only anywhere in the country. Okay, now, so how we define this? The distance traveled by light in vacuum, the distance traveled by light in vacuum in this much smallest second, this much of smallest second, fraction of second, that is a very minute fraction, means what is the speed of light? If you write this is the speed of the light, 299,792,458 meters it will travel in 1 second. In 1 second, the light can travel 299,792,458 meters. Now, if I want 1 meter, then I have to bring this number to the right hand side. That means 1 by 299,792,458 seconds. Now, so this is 1 meter. Means what? The distance traveled by light in vacuum in this much part of second. This much part, in this much what? Fraction, very minute fraction of second, how much length the light can travel, that is considered as 1 meter. And 1 kilogram, there is one prototype, a model. Prototype means what? A model of platinum iridium cylindrical model is there in France, where the headquarter of units and measurements is there. There they have kept a model. Why they chosen platinum iridium is it is a stable element which does not react with any other elements, which is a very stable form, because of which the magnitude will never change. If you take any other material, the material may react, and either it may reduce its weight or it may increase its weight because of the reaction with other elements in its surroundings. But the platinum iridium prototype will not react with anything, means how many years you keep it, the kilogram reference, the kilogram reference will be 1 kilogram only. It will not change. It will not change. That is the reason why we kept platinum iridium prototype. Okay, that is kept in the headquarter of the units and measurements. Now, next is time. So here the vibrations. The cesium atom, cesium 133 is the atomic mass of this. So cesium has different atomic masses. In that we have taken an atom of cesium having an atomic mass of 133. So measurement, these many cycles of vibration. So vibration means what? When any particle is vibrating, means, so this is the mean position. Now the particle will vibrate like this. It will go to some extreme position and again comes to the mean position and again vibrates to the other side, other extreme position. So from here it starts to one side and it will move to other side and it comes to central position, that is mean position. This is called one cycle. Means if you look at a simple pendulum, so simple pendulum, when you pull a simple pendulum, it will go up. This is the first motion, and then it will come down. This is second motion, and this it will again go up. This third motion, and comes down to the mean position. That is fourth motion. So all together 1, 2, 3, 4. So you have pulled it up from the mean position. Again it comes to 2. Again it goes to 3. Again it comes to 4. That is mean position. So from mean position again it reaches to mean position. That is one cycle. That is one cycle. Likewise, the cesium atom, the time required to make these many cycles of radiation. Okay, so that is 1 second. So the time required for completing these many cycles is called 1 second. Okay, so now this accurate measurement of time is very much essential. So these days we use GPS navigating system. When you enter any directions, when you want to move from one place to another place, you can keep navigation. The navigation will tell you how much time it is necessary to reach your destination. All these things it will tell. All the measurements it will take. So that much accurate measurements it is able to take because of fixing this cesium atom. So this much accuracy in measuring a second we have kept, because of which the devices which we are using, GPS, while using GPS, so GPS has to count the time. The GPS will count the time. The time in seconds is the reference of cesium atom. It takes cesium atom as reference. That time is taken as a reference for designing these applications such as GPS and atomic clocks, which are highly accurate. Okay, next, fundamental units. So these are the 3 fundamental units which we already discussed in the previous slide. Now the new fundamental units, that are electric current. So this is measured in amperes. The units are very important. Here time units are second and it is represented by S symbol. Kilogram is the mass unit, kg is the symbol, meter is the length unit, m, small m is the symbol of meter. Electric current, generally they measure amperes. how we fix 1 ampere? See, 1 ampere is a constant current that is maintained between two straight parallel conductors of infinitely length. So when you take two conductors where the lengths are infinite, these lengths are infinite and negligible cross section, these wires are having very least cross section, they are placed 1 meter apart. So the distance between these two is only 1 meter. Okay, so produces a force. So the force that is required between these two uh, wires is only the force is equal to 2 into 10 to the power of minus 7 Newton. 2 into 10 to the power of minus 7 Newton. So when the force between these two wires is 2 into 10 to the power of minus 7 Newton, then the current in the wire is said to be 1 ampere. So now here how we consider the current is 1 ampere, where the force, so we have taken two wires, infinite length, negligible cross section. Negligible cross section, what is meant by cross section? Cross section means when you cut a wire, so there is a wire like this, in your home there will be wire, right? So your wire will be having a circular cross section, so this is called the cross section. So where the wires are inside, so if you look at the wire, if you cut the wire, so look at the cross position, if you keep it in a cross position, you are able to see this cross section. So the area of cross section is negligible and the force between these two parallel conductors is 2 into 10 to the power of minus 7 Newton per meter. Then the current is said to be 1 ampere. Okay, so thermodynamic temperature measured in Kelvin. So thermodynamic temperature means, as I told you already, the transfer of heat. Thermodynamic. Thermo means heat, dynamic means moving. So moving heat, the measurement of moving heat's temperature is taken as Kelvin. Okay, so this Kelvin is also defined based on the triple point of water, where the water, triple point means a value of temperature at which the water will exist in the form of ice, in the form of liquid, in the form of gas. So the three states of water will be present: solid, liquid and gas. Such a form is called triple point, that is called triple point. So using this triple point of water, we have defined this Kelvin. Okay, so amount of substance, so any substance, how much it is there, especially for gaseous substance, we use this value mole. This mole, we generally take this mole value of unit in chemistry, not much in physics. In very few topics in physics we go with the moles, but majorly the mole, this unit, you will come across in chemistry. So referring to the number of atoms, so in carbon 12 isotope we take carbon 12 isotope, so its atomic mass will be how much? 12. Okay, 12 units is its atomic mass. Now if I divide this 12 with 12 grams, so because 12 by 12 is 1 only, 12 by 12 is 1 only, so now it is giving you 1 mole. It is giving you 1 mole. Now the last one is luminous intensity. We measure this in candela, which will tell you the intensity of light. So whenever light is emitting, so there will be intensity. The intensity of light we measure in candela. So the supplementary units I will discuss in the next class. Thank you so much.